Okay, so before we get to solve that inequality, we need to realize that the domain is not necessarily going to define the inequality, but it will be able to give us the possible values of x that will make a function to be defined and not undefined. So whenever you look at the rational function, we say that the denominator, which is x minus 5, should not be equivalent to what? Should not be equal to 0, because if it's equal to 0, it makes the function to be undefined, because any number, any expression divided by 0, it's undefined. Okay, so therefore x should not be equal to 5, meaning that the domain in such a case is going to be a set of all real numbers except what? So x is a member of all real numbers, all the numbers that are there, except it should not be equivalent to what? To 5. Are we together? Are we together? Okay. So does that mean that all the values is there? If we get any value, it's going to define that inequality, or there are some that may make it undefined? Let's do this. So what is it saying? We are told it should be greater than what? It should be greater than greater than 0. That's the inequality. So of course we've talked about, I'm just trying to remind you of what we talked about under the domain and the range there. So now let's try to talk about solving the inequality. How do you get to solve it then? So that's what we have. So how best can we solve it? So the best thing that you can do is try to look at the possible points that can make it to be equal to a 0. Okay, we call them critical points. Okay, so the critical points are actually defined by the numerator in terms of the rational function. So in this case, our rational function, we get the numerator, which is what? X minus 2. So our x minus 2, let's try to find the points where it's going to be equal to 0. Its x is equal to 2, right? So when you put 2 in that function, we are going to have a 0. Are we together? It's different when you say 0 over 2 and 2 over 0. This one is defined, that one is not defined. Okay, so let's come up with a number line there, we see. So we have our critical point there at 2. There are some good cases where you may have 2 critical points and you'll be able to make a decision by trying out the middle part and the left and the right. But in this case, it seems we only have a single critical point because the numerator is a linear what? It's a linear function. Let's try it out now. So let's start with a value is greater than 2, maybe a 4. Let's try a 4. Let's put in a 4 in that function. What are we going to have? We have 4 minus 2 over what? 4 minus 5. This is going to be equal to 2 over negative 1, which is negative 2. So if I ask you a question, is negative 2 greater than 0?
No.
It's not. You're refusing. It's not greater than 0.
No.
So 4 is refused. Let's try 10. Let's try 10. So 10 minus 2. Then 10 minus 5. What are we going to have there? We have 8 over what? Over 5. So that's a positive value. Okay. So our goal is to find the values that are giving us the values of x that are going to make sure that all what we have is what? All what we have are positive numbers, because positive numbers are the numbers that are going to be what? are the numbers that are going to be, they are going to be greater than what? They are going to be greater than 0, of course, starting from, yeah, a fraction, provided it's greater than 0. It's provided it's a positive number, it's going to be greater than 0. So what conclusion can we make so far from what we've seen? Is it all the values that are greater than 2 that are making it undefined, or only some?
Some.
Okay, so that brings us something now that we're going to, let's do this now. So our critical value in this case is a 2. Then the point that is making the function to be undefined is what? Is a 5, right? Are we together? Are we together? So we've tried a 4. We've also tried what? We've tried a 10. Let's try to get another value between 2 and 5. Maybe a 3. So 3 minus 2 over 3 minus 5. That will give us a 1 over what? 1 over 2, right? 1 over negative 2, or negative 1 over 2. Is that greater than 0? Okay. So all the values between 2 and 5 are making it to be undefined. Or are making it, yeah, not like it's making the function to be undefined, but it's not defining or satisfy. Okay, let's use the word satisfying. They are not satisfying what? The inequality. So this part has refused. So let's start from 6 maybe. How about 6? If you try 6 here, 6 minus 2, 6 minus 5, they will all define the function. Do we agree? The values will be positive. Okay? So the values of x that are greater than 5 will define the function. Let's try the one that are less than 2 to see what they're going to give us. The ones of at are less than 2 going this side. We can get a 1. So we have 1 minus 2 over 1 minus 5. What basically are we going to have there? What are we going to have? Negative 2, no. So it's going to be a positive value, right?
Yes.
We can get even a smaller number, maybe negative 10. It will be negative 12 over negative 15, which will still be a positive value, right? So it seems all the values going less than 2, they are all going to make the values greater than 0 in that function. So what is our answer? So the possible values of x that can define that inequality, that would make the values to be greater than 0. What are we saying? They have the values of x that are what? Less than what? 2 and what? Is it greater than 2 or less than 2? Less than 2.
Less than 2, sir, and greater than 5.
Okay. So how about 2 itself? How about 2 itself? 2 itself is going to make it a 0, right? So, meaning that if we add that greater than or equal to 0, we would have put that as well there at that point. Are we together?
Yes, sir.
But in this case, we are only interested in what is greater than 0, not equal to 0. But all the same, despite if we had added that there, that one will still stand the way it is without any dash, because it can be equivalent to 5, because 5 will make it to be undefined. And 5 would not give us a 0 anyways. Are we together?
Yes, sir.
Let's look at the next question. What is it saying? So we've solved the first inequality. So the second one is saying 2x squared Yes, Emmanuel.
So meaning like is it can you also like put it in interval notation?
Yes, 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 yes. Yes, yes.
Okay.
But how then can you present that one in interval notation? Unless if you come to say,
That
mhm.
that could be open bracket negative infinity comma 2 which is you said 2 it's included as well.
No, it's not.
Yeah, so meaning it will be negative infinity comma 2 close bracket. Oh no, the open bracket one. Then union open bracket 2 comma 5 open,
Not 2
then
5.
union
You are lost. You are lost. You are lost.
should be union then open bracket 5 comma infinity.
Okay, so we said the possible values are the values that are moving from 2 going less and greater than 5. So it's from the negative of the infinity or affinity to positive 2. Unionize it with starting from 5 going this side up to infinity. But again, if you put 2 and 5, this region is they are not defining it. They are less than. So they can't satisfy that inequality. That's why I was refusing 2 5.
Alright, thank you very much. I always find it easy when I use interval notation.
Oh, okay. Yeah, that's why you learned it to apply it. Okay, so the next one is a quadratic function. A quadratic inequality. So what basically do we have there? We have 2x squared plus 3x minus 14. So basically, I would advise you guys to work with the concept of completing the square method. And I've worked on a video that I've already shared to a YouTube channel. You can check it out if you've forgotten how to go about it. But anyway, let me remind you. So what basically do you get to do? So there are two ways of solving this question. Either you use the completing the square method or you find the critical points. Let's go by the critical points. You can look at the completing a square method and check it out. So let's take all these guys one side. We have 2x squared plus 3x. So we don't necessarily take it the other side, but we use the additive inverse. Okay. So you find that the other side will remain with a 0 and this side will remain with a negative 14. Okay. Are we together?
Yes, sir.
Okay. So let's consider it to be a quadratic function and a quadratic equation now, so that we find the critical values. So we have 2x squared plus 3x minus 14. Let's find the values that will make it to be equal to a 0. Okay, so by factorization, let's try it out. The product is minus 28. The sum is 3. I believe we all know how to go about factorization. And I've also made a video on that, in case you've forgotten. So what are the factors? What are the values that are going to... Can you multiply to give you minus 28? You had them again to give you a 3. I'm sure we are talking about 7 and 4 there. Now, provided the product is a negative, one value should be a negative. So it will be a 4 so that we remain with a sum of 3. So we have 2x squared. So the sum is supposed to be represented or replaced by the factors. Then what are the highest common factors? If you split these guys into so there you have the numbers. Of course, you don't have anything that is that you can use there, but you can instead use the variables where x is common. So you remain with 2x plus 7, right? Then the other part, the highest common factor in terms of the numbers, I think it should be a 2. then you remain with, let's make it negative 2 so that even what you have in the brackets will be positive as well. So we have 2x plus 7 being equal to what? To 0. So the first part is going to be x minus 2, 2x plus 7 equal to what? 0. So this is the way you solve. So this is also part of a max. So after factorizing, you can show it where you can say, okay, this is x minus 2, 2x plus 7. It's c. So we want this to be, is it less than or greater than 0 according to the question? It's less than, right? We want it to give us the values that are less than 0. Are we together? So now, as you're looking at that question there, let's look at the critical values like I mentioned. Let's look at the critical values. So if you get the first part of a factor there, x is going to be equal to what? To 2, right? Then the other part is going to be what? Negative 7 over what? Which is approximately negative 3.5, right? Okay. So the way you solve an inequality is either the middle part is a solution or these guys together, they are part of a solution set. So we can start with the middle part. So I believe between negative 7 over 2 and 2, there is a 0 there, right? 0 is one of the numbers between the two. So if you plug in 0 in the equation there, so x minus 2, put a 0 there, you have a negative 2 in that bracket. Then the other part, put a 0 there, you remain with a 7, right? So if I ask you a question, negative 14, is it less than 0 or it's greater than 0? So is this true or it's not true? It's true. Okay, so we are saying that the middle part is actually the solution to the inequality, right? Because they are asking for the values that are less than 0. Meaning that, obviously, if you get to go less than negative 7 over 2 and greater than 2, those ones are going to be greater than 0. So to just make sure that you came up with the right critical values, you can try out the other sides. Make sure that they don't work out. Then you are really confident that indeed the middle parties are the possible values to satisfy that inequality. Are we together? So let's try out above 2. Above 2, what can we get? We can get a 3, right? We can get a 3 after that. So if you plug in there, 3 minus 2, what do you have? It's a 1. Then where there is x, put a 3 to be 6. 6 plus 7 is what?
13.
So is 13 less than 0 or greater than 0?
Greater than 0.
It's greater than 0. So is this true or it's not true?
It's not true.
So we can say that part has refused, okay? So refused, agreed. So this, I said negative 7 over 2 is the same as negative 3.5. So you can get a minus 4 because it's coming after. So if you put a minus 4 there, it will be minus 6. Then the other part, minus 4 multiplied by 2 is what? Minus 8 plus 7. It's a minus 1. So that is obviously going to be a 6. Is a 6 less than 0?
No, it's greater than.
Okay. So even this part has refused. So the possible values are between negative 7 over 2 and what? And 2. So how do you get to present your solution then? So you are saying negative 7 over 2 is less than x, right? But x is also less than what? Less than 2. So if the question had an equal part down there, would have put the same down there, because that would mean that negative 7 over 2 and 2 are also part of the possible solutions. But in this case, they are not part of the solutions. They are just telling us that only numbers between them are actually going to define the given inequality. So in terms of set interval notation, how would we present that solution? So this one doesn't require you to use the union, it will just be one set. So what brackets are we going to use? Is it curved or square brackets?
Curved.
Okay, so if you've not understood set interval notation, check out the video on the channel to understand what really that means. Okay. So that's it about inequalities. I think let's go to maybe question question what? We can even start with just with this very one. Is it the third one? Let's solve them in that order. So we have x to the power 3 divided by what? Divided by x squared plus 1. We want values that will make this to be less than 0. Okay, so is it possible that you can divide that? Is it possible? Now we go let's take it directly. So let's try to predict the critical values and the values that can make this one to be undefined. So x squared plus 1 should not be equivalent to what? Should not be equal to 0. So x squared should not be equal to negative 1. Is it possible that x squared can be equal to negative 1?
No, it's not.
It's not. Unless maybe if it was a negative there, it would have made sense. But it's not possible. Meaning that all the values of x on the denominator are always going to be positive. So it's not possible for you to have a 0, no matter what number you get. It will not be possible, right? Are we together?
Yes.
So in this case, there are no. In such a case, when they ask you to find the domain, you would just say that all the values, all the set of real numbers are part of the domain, because it's not possible to get this function to be undefined. So coming up with a number line, looking at the critical values, we're only going to have 1, I guess. So we expect that x to the power 3 should be equal to what? To 0, because that is the only way, the only possible way that we can have a 0 in this function, if the numerator is equivalent to what? To 0. So if you find the value of x that can make that to be 0, it's only 0 itself, right? Looking at the numerator, only 0 can make it to be equal to 0, right? Not any other value. Not so.
Yes.
So now, let's ask ourselves a question. Let's try out the values that are greater than 0, maybe 1. Let's try to plug in there. So 1 to the power 3 is going to be what? I'm looking at the numerator first of all.
It's 1.
Then down there, 1 squared plus 1. It will be 1 plus 1. So 1 over 2. Is it less than 0 or it's greater?
Greater.
So is this side defining it or it is refusing?
It's refusing.
Then let's try out the values that are less than 0, maybe negative 1. So negative 1 to the power 3 is going to be what? Negative 1.
Negative 1.
Then the down part will still be what? It will still be a 2.
2.
So we have negative 1 over what? We have negative 1 over 2, not so? So basically, this makes sense. Only the values that are less than 0 are going to define that. How? How do you explain it? The reason is because if you look at the numerator there, what you have is something that will always produce positive values, meaning that for a value to be either negative or positive, what is determining it is the numerator. And it being an odd power, all the negative values will remain negative. Okay? And all the positive values will remain positive. So the positive values going this side will come up with values greater than 0. Then the ones that are less than will be what? Will come up with values less than 0. I don't know if that makes sense.
Yes, very much.
Okay, so what can we say now? So we can say that in this case, the values of x that are going to define that inequality should be what? Are they
Less than 0.
they should be less than 0, right? So if there was an equals part there, I would have put it there, but we are only interested in the ones that would make them less than 0 and not equal to 0. Are we together?
Yes, sir.
I think let me just solve one more so that you can now practice, because sometimes you may feel you've understood, but if you don't practice, the time when you're given a quiz, you feel maybe you've never studied that topic before. I think we can answer this very one. So x squared minus 4x minus 21 over 3x plus 9 should be greater than 4x minus 28 over x plus 5. How would you answer that question? How can you answer it?
For the one on the left, that quadratic equation on the top part of the left side, I think we have to factorize it to come up with factors. Thereafter, yes, for the start, I think we have to come up with factors.
Okay, so you are looking at a possibility where they can cancel out. That's what you're saying, right?
Yes, sir.
Okay.
We have to
Cross and multiply. Okay. Are you not going to complicate your life?
I think cross multiplying, because there we only have the greater than sign. It's not greater than or equal to, so that one.
Crossing and multiplying. you can try it out. You'll see how stuck you're going to be. Okay, let's try out to see if it's going to cancel out. Let's try. So we have x squared minus 4x minus 21. So the product there is a minus 21. The sum is a minus 4. So what possible values do we have as our factors? 7 and what? Okay. So x squared minus 7x plus 3 x minus 21. So trying to factor out there, what are you going to have? So you have x, then you have x minus 7, you have plus 3, then you have what? X minus 7. So basically you have x plus 3, x minus what? 7. Are we together? So the guy was kind of predicting, and usually it's the case because they don't give you enough time for you to begin multiplying, but they expect you to reduce it as quickly as you can. So you have x plus 3, you have x minus 7. Now, can that cancel out with what is on the denominator part? Of course not. Factor out
Just a minute, sir. Yes, okay. Continue. I was going to that part.
Okay.
So I think it can cancel out because you factorize the done part, which will be 3x plus 3 into 9 is 3. So we'll remain with the 3.
Yeah, I was trying to bring in a point to say you can't cancel out directly unless if you get to factor out that. Okay, there we are. 4x minus 28, x plus 5. So that can go. So you now have x minus 7, which is at least easier to work with. Not so.
Yes, sir.
So at this point, what should we do? What should we do?
So how about bringing this 4x minus 28 the other side so that it will be greater than 2?
That's the easiest way to go about it. So we can add that by finding the common what? The common denominator. So which is going to be a product of the denominators that we have. So if you divide the 3 into that, you have x plus x minus 7 being multiplied by x plus 5. Then the other part you have what? You have 3 being multiplied with what?
4x minus.
Okay, so simplifying that, x multiplied by x is what?
Square.
X minus 5, 5x minus 7x. So 5x minus 7x is what? Minus 2x. Minus what? 35. 7 by 5 is 35. I'm trying to test your memory. I'm trying to skip some of the steps to see if you're going to follow. Okay. So 3 by 4 is what?
12.
Then 3 by 28 is what? Is it 84? That is like 3 by 8.
Yes.
Okay. So is it positive or negative?
Positive.
So let's try to subtract now. we have x squared. So minus 2x plus 12x is what?
minus 14x.
Then 84 minus 55. So that is like, you need to be used to working without a calculator because calculators are not going to be allowed. So 14 minus 5 is what? Is it a 9?
Yes, 9.
Then that is a 4. Plus 49. Over what? Over 3x plus 5. Okay. So the next step, it's a two-way thing. It may work out, it may not work out. So the next step that you can take is try to see if it's possible for you to factorize what you have as your numerator there. Just in case. X squared minus 14x plus 49. The product is 49. The sum is what? So the factors is negative 7 and what?
Negative 7, sir.
Okay. So basically you have x squared minus 7x plus 49. The highest factor there is x. So x minus 7. There it says minus 7.
Negative 7.
X plus what?
7.
Okay. So it's just like you just have x minus 7 squared, right? We only have x minus 7 being multiplied by itself. So we have x minus 7. We have x minus what? 7 over 3x plus 5 being greater than 0. That's where we are. How are we going to simplify it now? So we said in this case, first of all, if you look at of course, if you look at the what? The denominator, make sure that you remove all the values that can make it to be undefined, right? So if you get 3x plus what? Let's say 3x plus is it 15? It should not be equal to 0. So 3x, so you find that our x should not just be equal to negative 5, right? Are we together? Are we together?
Yes.
Because x, when x is equal to that, it's going to make it to be undefined. So it should not be equal to negative 5. So let's come up with our number line. We see what we're going to have from there. Okay, so coming up with our number line, something like that. Okay. That's what we have. So what are the critical values? What are the values that can make this function to be equivalent to a 0? Only when x is equal to what? So I can even simplify it so that I just put it this way. Since it's the same, it's just x minus 7 squared. So only when x is equal to 7, that's when it will be equal to what? To a 0. Are you getting me?
Yes.
So this is an example of a function with what we call equal roots. Whether you say plus or minus, you still find the same value. Okay, so we have 7 as one of the determining points. We can also use the one that can make it to be undefined, minus 5. So I'll start with asking a question. What value is between negative 5 and 7? The smallest, so that it can help us simplify it faster.
0.
It is 0. Okay. So what do we have? So if we plug in a 0 there in the looking at the denominator or the numerator. 0 minus 7 is a 7. It's a minus 7. Now a minus 7 squared is going to be what? A 49, right?
49.
Over. Then get the 0 plug in down there. 0 plus 5 is what? It's a 5. 49 over 15. Is it a positive value or a negative value? Okay. So it turns out that I think we're going to have positive values between the two. So we can try out another one. Maybe let's say we get a 1, for example. If we get a 1, it's like what we're going to have again is going to be what? A positive value. Okay. So in this case, what am I trying to say? If you look at the previous case that we had, it was the numerator that was determining because it never had a square. But in this case, the numerator is not determining. Why? Because all the values that you're going to put at x on the numerator, they are going to define it, right? You're going to see that x is actually going to be what? Whether you put a negative value, a positive value, you're still going to have a positive value. So it is not determining anything. What is determining the sign of a solution is what? The denominator. Are we together? So meaning that the only possibility of having a negative value is when you get to the negative numbers. And those negative numbers should be less than minus 5. Let's try it out, we see. Let's get negative 6. If you get a negative 6, of course, forget about the numerator because it's going to be a positive because of a square. So look at the denominator. If you put a minus 6 there, it's going to be what? A minus 1. Minus 1 by 3 to be a minus 3, which is going to be less than 0. Are we together? So now, we are interested in the values that are going to define it, that are going to give us something that is going to be what? Greater than what? Greater than 0. So, how can we look at that? Greater than 0. So, this part has refused. It's giving us something less. Between negative 5 and 7, we are finding it is working out. How about the values after 7? Do you think they're going to work out? Do you think they're going to work out? Are they going to make the denominator to actually be a negative number? Or it will still remain positive? What do you think? So in this case, only one part is refusing, right? So all the values that are greater than what? All the values that are greater, all the values of x greater than what? Are going to define the function. Are we together? Now the question is this. No, this requires you to be thinking, like, think beyond.
So like now
Wait, Emmanuel, wait. Yes, wait. I'm saying x is should be greater than minus 5. So, if you look at this again, it's taking us to 7, like you wanted to say. So how can you put it now, since you've identified that error? But if you look at 7 is going to give us a 0. But we are not interested in a value that is going to be a 0, only greater than 0. What should you do then? What should you do? How can you present it? You want to exclude 7 because it's giving you a 0.
okay, so like as for me, what I'm thinking is it can be in interval notation. That could be negative open bracket negative 5 comma 7 open, then union open bracket 7 comma infinity.
Makes sense. It makes sense. Because in that case, unless again you come and say x, but x should not be what? Should not be equal to 7. Yeah, that's also fine. Whichever is easier for you. Are we together? And so I think this question has encompassed like all the questions that are coming after. If you check the last two questions on that question, they've all been covered by just that. Okay? Are we together? So
Yes.
I think that's it under inequalities. That's it.